The next challenge is Web Unfinished. This was a challenge by Strelic. It says, it's the day of the CTF and I haven't finished writing this challenge. Well, unfinished doesn't mean unsolvable. We're given a instancer link and a download file. I was excited for this challenge. Strelic usually does very good web challenges, and it was a very good challenge. I am salty though because I got to the final stage and I did not solve it, and I'm even saltier because at myself, not Strelic, at myself, because it was a MongoDB challenge, and I feel like I probably shouldn't be admitting this, but I used to work at MongoDB, and yeah, I didn't get it. I thought about doing the CSRF or the server-side request forgery, but I just didn't think that'd be possible over the wire protocol, but it definitely was. So great challenge, and I'll try to stop being bitter that I missed it. Anyways, like I said, I did not solve the challenge. There's two write-ups. Oops. There's two write-ups. The first one here by Trickster. They gave their solve script, and the challenge author also gave a solve script. A write-up. All the challenges authors are putting their write-ups here. So if we go to web and then unfinished, Strelic, and so highly recommend checking both of these out. They're both very good. Cool. So let's start the instancer link, and let's check out the download files. So we're given two folders and a Docker Compose file. So let's look at Docker Compose. So it has a build app and build Mongo. Let's take a look at the Mongo. This is something I added. We might use that in a second. This is the init file within the MongoDB Docker container. So it's going to create two databases, one called app, one called secret. In the app users collection, it's going to insert a document with user and password, some random hex. We don't end up using this one. And then it's going to create another database called secret, a collection called flag, and insert a document that has the flag. So our goal is to exfiltrate data from this MongoDB database. Let's take a look at the app. So it's a Node.js app. We're given a package file, a Docker file, app, and some static files. Within the app file, so it's going to use the Mongo client. So this is the official Node.js driver, child process. So maybe there's a remote code execution. It is interesting that we had to use an instancer for this. So we're getting a private Docker container, which usually means we're going to break something or leave something unusable for other players. That's why we get a private instance. So when you see this and shell execution, like just things to think about, but it ends up not actually being shell execution. Then we also have a Mongo client, so it's connecting locally to the other Docker container. URL encoded, extended is false, so we're not going to be doing those like fancy characters like this in a URL. It's going to have some sessions. This is my code. I'll talk about that a little bit later. The first bug is here. So we have some middleware. You can tell it's middleware because of this next parameter. It says requires login. It's going to check if there's a user on the session. If not, it's going to redirect. Otherwise, it's going to continue. I love this bug. I make this mistake all the time. You're supposed to put a return here. The code will keep continuing, and you'll get an error. It'll say like cannot send headers twice or something like that, but it will continue executing. So whenever you do a res redirect or res.send or something, you make sure you have a return there. So that was the first bug. There's this login route. We can't actually hit this one because we don't have username password. If they weren't doing this password check for string, there's a common MongoDB injection where you do something like this, not equals to A, for example. And since password is not equal to A, you'd be able to log in, but it's doing a string check, so we're not able to do stuff like that. So we're not able to log in. Then there's this ping route, which I'm going to talk about because that's kind of the meat of the challenge. And then a static handler down here and connect, so setup. Cool. So all that we can really do is this ping route. So again, it requires login, but we can bypass that, thankfully, because the middleware isn't calling return. Also, if we look at the Docker file for the Node.js app, something interesting is happening at the very end. So it's going to install curl, and there's also this disabled share, disabled gopher, which is interesting. But then it's going to copy curl into the final Docker container. It's going to install CA certificates. This strace is mine. I'll talk about that a little bit later. And nothing too exciting. I didn't see this at first, which was one of the mistakes I made. And then at the very end, it's going to do this while true do node app.js. This kind of signifies that the app is going to be crashing every once in a while, or what I thought is we're supposed to replace app.js. But anyways, so like I said, requires login doesn't actually work. It'll still execute this code. So if we look, it's going to do, let's actually jump to the very bottom. The very last thing it's going to do is child process spawn. So it's going to call curl with a set of arguments. And we can see it's going to be adding stuff to the arguments here. And so basically, we can see we're going to be able to somehow take control of this argument array. So anyways, back to the top, rec.body. It's going to grab URL from there. It's going to parse the URL, make sure it starts with HTTP or HTTPS. Then it's going to grab opt and data from our payload. It's going to make sure they're both strings. It's going to make sure the opt parameter is just a single dash and then a character. And then it's going to check that either opt is equal to -d or opt is equal to, the data is equal to get and post. So interesting set of requirements. The bug, or I guess the exploit for this is we can only one of these has to be true. And so what we're going to actually do is we're going to use the -k parameter and call our file get. So -k is how you specify config with a config file with curl. So you can pass more arguments. And we're just going to name that file get. So as part of our exploit script, we're going to be downloading files, naming them get, and then using that file on the next call with the -k parameter as our config. So really, we can get curl to do anything we want. Cool. So at this point, we can download files to disk. We can upload files from disk. So maybe we just need to do a quick exfil or overwrite something. When I saw, after I figured out reading the curl docs, so I was still able to get to this far during the CTF. I saw that we could do the config, so we can get curl to do pretty much anything we want. At first, I thought we were supposed to overwrite app.js. Because app.js, we saw in the Docker file, app.js is going to run over and over, even if it crashes. So I figured we'll just replace it real quick. I added this flag call right here. And so I figured, I'll just add an extra route. We'll use curl to download and overwrite app.js, and then once it boots back up, we'll call flag. The problem is, if we go back to the Docker file, we'll see that they add a new user. And this makes things much more complex. So this new user is added. Everything up here is running as root. And now that we're the user, this is like a nobody user. They're not able to modify root-owned objects. And they can't really write to anything either. So as soon as I got here, this is where I got stuck. Let's take a look and see what it actually looks like. Where are we? Unfinished. The app. Terminal. Let's do a reset. Ignore all that. Okay. Oops. Who am I? Let's remove all that stuff. All right. So we are running as the user person. And if we were to go to root and do find writable, we'll see there really isn't that much that this user can touch. So we're looking for some sort of privilege escalation. Like I said, we can write anything to disk with that curl. We just do curl output file. So we can write to procfs. I tried doing some stuff in here, but I couldn't really figure anything out. We can also write to our home directory, which is interesting. So there's home user, there's home profile, bash rc, and bash logout. I spent some time with bash logout. I was hoping maybe somehow we could trigger a bash logout, like maybe when the container dies, it'll do a bash logout, but I'm pretty sure everything runs as shell, and on this box, shell is different than bash, and so I don't think bash logout is ever called. And then otherwise, we really just don't have much. So naturally, whenever I'm at this place, I go to linpies, Linux linpies. I didn't think this would find anything, and it didn't, but I feel like it's always just good to check. To check it, you just take this command, and it'll enumerate the box and find a lot of good stuff. But there's nothing here. linpies didn't report anything. It did show, something I did forget to check is ls, I should do lsla. There's this docker end file, but it was empty here. So that didn't work either. And at this point, I was stuck, and I had to give up. But after reading the write-ups, there were two different solutions. There was an intended one and an unintended one. The intended solution was to actually use curl's telnet protocol to just do a manual telnet request to MongoDB and get the flag, which is crazy. I've seen an exploit where they do that with Redis, but I wouldn't have guessed that would be possible with MongoDB. Like the wire protocol is a little bit complex, and I would assume it was still doing a challenge response, but I guess if you're not logging in, there is no challenge response, and you can just send a raw payload. So I'm going to talk about that one later. because I'll show how to generate the payload. But first, the unintended solution, and I got help from Strelic from this one because I didn't quite understand what was going on. Let's go to present. He just showed me how to do this down here. So what we can do is, let's go to user. Node.js will load random files that it's really going to search for files and see if it can use them depending on the package, which I'll show now. So rm/rf, normally this node modules isn't here. So I'm just going to delete that real quick. So what we're going to do is we're going to see what files Node.js is requesting. And so we're going to use strace. Strace wasn't installed by default. I just added it to the Docker file. We're going to do node, and then we're going to do app.js. And we're going to pipe all of that to strace.log. Cool. Runs for a second. Maybe more than a second. There we go. Cool. Then we can cat strace. It's a very large file, so we're just going to grep and check out home. So it's going to do a statx, so it's going to see if this file exists or this directory exists, node modules. So we can make that real quick. Make directory node modules. Now let's run strace again. So what's going to happen is, like I said, we can write to files using curl. And we're finding out that when we run node app.js, which is happening in the Docker container, it'll look for this directory. And it's also looking for these files, which is super interesting. It's going to look for user node modules kerberos package.json, which doesn't exist. It's going to look for kerberos, doesn't exist. And then it's going to look for kerberos.js. It's also going to do this for Z standard. I think maybe this is time zone stuff. It's also going to do snappy. This is a compression protocol used by Mongo. And then AWS is also going to look for some packages here. So we can just put a file here, and that should work, which is crazy. I'm frustrated. I was looking for maybe a .npm rc or like a node.js rc config files. I don't know why I didn't run strace. If I'd run strace on this, so it obviously would have been very easy to see what files are being loaded. But I guess this is why you do CTFs. You always learn from your mistakes. So anyways, we can put an exploit here, and Node.js, when it boots up app.js, it'll try to load this file. So I wrote a quick exploit script. Here's one. So this is one of these solutions. So we could download this file and put it at the kerberos.js. And then when app.js runs, it'll run this file. So it's going to require Mongo. You need to do a full path because it's going to be in a weird location. Then async.start. We're going to create a Mongo client. We're going to query the flag database, do our await. I just print out the flag, and then I fetch it, and I send it to a webhook site where we can call it. And we can see that this works. We'll just, echo, hello? Reset. This keeps breaking on me. Reset. Echo, exploit.js. And there's the flag, and here's one. 1:49, yeah, it's the current time. And so there's the flag. So that's one way to steal it. This was the unintended solution, but obviously a lot easier than the intended solution, which I'll talk about now. Let me get rid of this, remove exploit and strace. So the intended solution was to actually use the telnet protocol to send over a raw MongoDB wireprotocol query and get the flag. Cool. So I think the challenge author had the wireprotocol buffer from another challenge, and which they copied over. I ended up just generating it myself, and I'll show how to do that in case you need it in the future. I think it's under notes. So first thing we're going to do is we're going to start a MongoDB container. Cool, so now Mongo is running on port 20,000. Sweet. Then we're going to open up Wireshark. Do I have it open? No. Should have opened up this earlier. For some reason my indexer is broken, so I have to load everything manually. pretty slow. It's going to be going over local loopback, so we'll just start it here. Then we're going to make a query. So we're going to load Mongo, do port 20,000, and then eval this. And so this is our query to get the flag. And so we can just run this anywhere. Bam, and there's the flag. And so here we have it in Wireshark. And so then we can just follow this TCP string, follow TCP stream. Cool, and this is the what went back and forth. Really, we only want the one direction. So this is the response. You can see DiceCTF here. So we want the other way, this way. And so this is the payload that was used to generate that. Then you can just change this to raw and you save it to file. So I already did that, and it is under payloads. Cool. Here, and then you can also just do this to make sure that, actually, we'll just do that. Curl, telnet, it should be localhost 20,000, t payload raw, and we'll just take a look and see what this says. Let's see if this works. Oh, not enough. cdc, dice, web, unfinished, payloads. Bam, just like that. So it freezes for a second, but anyways, like I said, curl, we're going to do a telnet to our local host. This is Mongo with a T. This is our upload file, payload.raw, which is that payload we just generated. And somewhere in here, we should see flag. There's secret flag. Where is it? Maybe I need to run it again. Should be somewhere here. Okay, let's output it then. lol.text. Let's see if it's here now. Nope, and let's kill it. Now is it here? Strange. Maybe we do need the max time in here. So you can see it doesn't actually close. So let's do max time 1, so we only let it run for a second. And here we go, and let's see if dice exist. Oh, I know what I did wrong. Whoops, I never actually created the flag. That would explain that. Mongo port 20,000. Cool. We're going to use secret.flag.insert flag dice game. Missing a bracket. Oops, db.flag. Sweet. Now let's try. Please work. LOL. Let's see. Dice gang. Cool. And now we have the flag. Okay, so our payload is working. Sweet. Okay. So now we have a payload that we can send to MongoDB that will print out the flag. So this is the solve script. There's 5 different steps. And we're going to go through them one by one. And we'll just do it live while it's running. Do we need this? No. CD. CTF, dice, web, unfinish. And I'm going to run this at the same time. Python. We have ngrok running. If I was smart, I would put these in a tmux, but I'm not. Python 3, solve. All right. Oh, and let's run this locally. Cool. All right, step 1 just ran, and a couple things popped up, but we're going to do it all at the same time. So step 1 is we're going to download the config file for the MongoDB CSRF. Cool. So again, we're going to hit that API ping route with a URL to an ngrok we control. So this is an ngrok. It's running here, and it's pointing to a Python simple server. This is the command. We can make this a little bit bigger. Here's the simple HTTP server. We got an ngrok here, and it's going to download a file called mdb csrf.config, and it's going to output that to a file called get. So if you remember, opt can be either /d, or this has to equal get or post. For all of these, I think we just use get or post, and then we use whatever we want here. But let's take a look at this MongoDB csrf config. So like I said, this config file that you specify with a .k allows you to pass arbitrary command line arguments to curl when you call it. And so this will use the URL telnet.mongodb. We have to specify when we call curl. So we're going to call like, I don't know, something like this, conrad.io -k, and then mdb ssrf.config, we're passing a URL here, and we're also passing a URL here. So there's two different URLs. So when we apply parameters, we have to do it twice. So we're saying for the first one, upload a file. For the second one, upload a file. And then output the file for the first one, which is conrad.io to dev null because we don't actually want it. And when we send our payload, we want to send our payload, the one that we send to MongoDB, we want to save it as flag.txt. So this is our first set of config. Where's the sol file? Cool. Then, so we're going to send that curl config file. In the second step, we're going to download our MongoDB wireprotocol injection. So let's do that. Bam. So we can see we got a hit on our Python simple HB server. We also got a hit here. And every time we do this, the server restarts because because of that middleware issue where it sends the headers twice, it'll crash and reload. Cool. So now if we were to go into the Docker container, ls change, I think it's under temp. We now have a file called get and a file called post. And so if we were to cat out get, this is that config file. And if we were to cat out post, that's the wire protocol stuff, which is kind of a binary file, so I'm not going to cat it out. Our next step is to actually perform that server-side request forgery. So we're going to ask curl to speak over the telnet protocol and query MongoDB. So I'm going to hit enter. It should be doing that. And so now the output file, one of these output files should have the flag. Let's see. So the output file is going to flag.txt. So if we did it right, there should be a flag.txt, and there is. Cool. So if we do strings, the strings here, no, it's not. Okay, we'll skip that for now. Then, so we have a flag.txt. We can't immediately exfiltrate the flag.txt because we're only allowed to work on files called get or post. So we're going to create a new config file called flagexfil.config, and it's just going to upload the file flag.txt. So we hit enter. We're going to grab this config file. So we just grabbed flagexfil. And then the very last step is to actually exfiltrate it. So the exfil step, this flag_exfil, it's going to do upload file, and we're going to send it to this webhook URL, which is this one, AE something, and that's this one. Sweet. And so when we hit enter, if we're lucky, we should get a new web request, and we do. And it is empty. Something went wrong. Definitely should not be empty. Flagexfil.config. What did I mess up? So we have a flag.txt. Cool. Do we have a upload file flag.txt? That's troubling. What am I missing? Let's just run it again real quick. One Mississippi. Something is not happy. Oh, am I running this remotely? No? It's this one. Is this the correct B2BB? Yep. That's the correct one. For some reason, I can't do a post. Okay, it worked that time. I'm not sure what's going on. We'll wait for the server to start back up. We'll do the exploit. We'll download the new file. And we'll exfiltrate. I don't know what went on there. For some reason, it didn't send the first time. I haven't seen that before but anyways, here's Dice test flag. So we were able to exfiltrate the flag. I'll look into that later, and I'll leave a comment on the video if I figure it out why it didn't work the first time. But there it is. So we can try running this remotely. Just finished. Traffic lights. Sure. This takes a minute to start up. Was there anything else I wanted to talk about while that's loading? I don't think so. Still loading. Flag_exfil. Yeah, I'm not sure why that wouldn't have worked the first time. That's interesting. Anyways, let's run it. So we're going to do Python solve. So now this shouldn't matter anymore. This is the Docker container local, but we should be able to see it grab the files off of our ngrok. So we're going to run it. The first file it's going to grab is it right? I'm doing something wrong here. Unfinished. Maybe I don't need this. There we go. I had an extra trailing thing. Cool. So it grabbed the MDB cserf config. Sweet. Step 1. Then it's going to grab payload.raw, and then the server's going to restart. So give it 5 seconds. Then we're going to execute the MongoDB cserf payload, or srf payload. Sweet. So now it's copied it. There should be a flag.text on disk now. We're going to give it 5 seconds. Now we're going to download the flag exfil. Hopefully we see here. Sweet. Now we have the flag exfil file on disk. And then with the very last step, we're going to exfil the data. And hopefully this worked. Where's our webhook site? Sweet. And there it is. Flag, dice, I lied. This is the finished state. So sweet. Amazing challenge. A lot of fun. I learned a lot of things. I'm still mad at myself for missing both of those exploits, but it was a cool challenge. So thanks. See ya.